So we've looked at J.J. Thomson's work with cathode rays and how it led to this understanding of the plum pudding model, where these electrons are these very small negatively charged particles that are plunked into this larger positive framework. So we called that the plum pudding model or the chocolate chip cookie model. What we're going to look at is an experiment done by J.J. Thomson's student, Ernest Rutherford. And this led to a redevelopment of the atomic model. It led to the nuclear model or the planetary model, where we have this nucleus containing protons and neutrons, and these negative electrons outside orbiting that nucleus. Now, Ernest Rutherford did this by using something called an alpha particle. Alpha particles are basically helium nucleuses. If you look at them, there's 2 protons, 2 neutrons, and no electrons. It's a helium nucleus. So we call it, sometimes we represent it that way, sometimes we represent it that way. And what Ernest Rutherford did is he took these alpha particles, which are emitted from radioactive sources, and he shot them at different materials. And he looked at how they actually interacted with that material. Now, the revolutionary experiment that he did involved shooting these alpha particles at a very thin piece of gold foil. This gold foil was so thin, it was only an atom or 2 thick. Now, going into this experiment, if we use J.J. Thomson's model and assume that it's correct, what we would expect of these alpha particles is that they would travel straight through. This positive charge is so weak because it's so distributed over such a large space that these alpha particles would travel straight through that atom. So in that experiment, we would expect that these alpha particles would travel straight through and be detected over here on the detector screen. That was Ernest Rutherford's prediction going in. Now, what Ernest Rutherford observed was something different, which caused us to revise the atomic model. Now, a majority of these alpha particles did travel straight through and end up here at position A. However, every once in a while, an alpha particle would be detected over here at position B. And sometimes an alpha particle would hit the gold foil and be turned back and be detected over here at position C or somewhere along there. So this is what was predicted. But then all of a sudden, Ernest Rutherford saw some evidence that did not support J.J. Thomson's model. So he made an inference based off of that. What Ernest Rutherford determined is that nucleus, that positive charge, must be very small and it must be positively charged. Now, the reason why Ernest Rutherford thought it must be very small is because a majority of alpha particles traveled straight through and were not altered as they hit that gold foil. The reason why he thought that it must be positively charged is because every once in a while those alpha particles were turned back. And we know that a positive charge is going to repel another positive charge. But it only happened every once in a while. So it must be a very small region, and it must have a very strong positive charge. So those were the inferences that Ernest Rutherford came up with. And he came up with this model, which we call the planetary model, or the nuclear model. And you'll notice that we have our positive nucleus here. Now, one thing you'll notice looking at it is there are no neutrons. And the reason for that is at the time, no one had discovered them yet. So we have this positive region in the middle. This is our nucleus, so where the positive charge exists. Now, based off of off Thomson's model, we had evidence of electrons. Where Rutherford put them was outside of that nucleus orbiting it. Now, that assumption would cause problems later on. And we're going to look at that in the next video. How these electrons cannot be orbiting around that positive nucleus because we know that things traveling in a circle are accelerating, and if a charged particle is accelerating, It must be emitting EMR. Now that caused a lot of problems with this model and led to further revisions down the line. But Rutherford's experiment was very surprising. Rutherford himself said that it was almost incredible, as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. And the results of his experiment led to a shift from Thomson's plum pudding model to Rutherford's new model, which is the planetary model or nuclear model.